Hello all. Today we are going to discuss the concept of basic comparator. The circuit diagram of basic comparator is as shown in the figure. This one. As the name itself indicates, it will compare something. Then what it will be comparing? It will be comparing the two input voltages that are applied to the two terminals of operational amplifier. You will be knowing that the operational amplifier will be having two terminals, that is the inverting terminal and non-inverting terminal, negative and positive. In order to understand the concept, we need to consider that we are going to apply the V reference of plus 1 volts to inverting terminal and a sinusoidal wave, that is time varying signal, to the non-inverting terminal, that is positive. Then what the operational amplifier will do? This will start to compare the two voltages, this plus 1 volt with this sinusoidal signal. Whenever the input voltage V in is greater than this V reference, V in is greater than V reference, then what happens? Non-inverting type terminal. If the input is connected to type of terminal, the output will be non-inverted type only, right? If V in is greater than V reference, the output will be what then? Positive saturation voltage plus V sat. Clear it is? Then if this V in is less than, if this V in is less than V reference, if it is less than V reference, then what happens? V reference is greater now, V in is less, so the output will be depending upon the greater voltage. The greater voltage, that is plus 1 volt, is connected to inverting type. If the input is given to inverting type, the output will be what? Inverted type, means it will be minus V sat. What it will be? Minus V saturation, right? Clear it is? In order to make it more clear, I will tell you with one more example. Whenever the V reference is plus 1 volt, let us assume we will be applying minus 0.5 volts to this non-inverting type of terminal. Now compare this 1 volt with 0.5 volt, that is minus. What happens? Which one is greater? This 1 volt is greater. Then the output will be depending upon this terminal where the greater voltage is applied, that is 1 volt is applied, means the output will be inverted type, right? It is. Now see, if instead of applying minus 0.5 volt, I will be applying plus 5 volt. Now compare, this plus 5 is greater than this 1 volt. Now the output will depend on the terminal where this greater voltage is applied, means the output will depend on non-inverting terminal, means the output will be non-inverted type, that is plus V sat. The operational amplifier will compare the two voltages. Which voltage is greater? Depending upon that polarity, the output will be depending. See this. This is the output waveform for the basic comparator. Whenever the input voltage is greater than this V reference I have taken as plus 1 volt, input is greater than this V reference, the output is positive only, right? Whenever this input voltage goes below this V reference, whenever it goes in a negative direction below V reference, it will be minus V sat. Again and again the output will be shifting from plus V sat to minus, minus V sat to plus. How? By comparing V in and V reference, right? It is. Here what we have did is, we have taken the V reference as plus 1, that is positive V reference we have considered. And in the next case what we can do? We can take the V reference as negative also, right? It is, instead of taking plus 1 as V reference, we can take it as minus 1 volt as V reference also. Then we will get the waveform, output waveform like this. This is the next case, right? Now whatever we have discussed is about non-inverting type of comparator. because we are applying this input voltage V into non-inverting type of amplifier, non-inverting type of the terminal, right? Then the next configuration can be inverting type of comparator. What we need to do there? In an inverting type of comparator, we need to apply the input voltage to inverting input terminal. Now see, this is the circuit diagram of inverting comparator. Here we have applied this V in to negative type of terminal, and the V reference we are applying to positive type of terminal. This is the difference between the inverting and non-inverting type of comparator. Here what we are going to do is, the V reference we are taking through the potential divider. Here I have connected this potential divider to VCC and VEE. Already the operational amplifier will be having the plus VCC and minus VEE voltages. To these voltages only have connected a potential divider. This potential divider can be adjusted through the wiper. This wiper is connected to positive terminal, that is non-inverting terminal. Now what we can do? We can connect this wiper either towards plus VCC or either towards minus VEE. Right, it is. If the wiper is moved towards minus VEE, the V reference will be negative. If the wiper is moved towards plus VCC, then the V reference will be positive. Right? Like this, we can set the reference voltage, that is V reference. It may be either positive or negative as desired. After setting the V reference, what you can do? The comparator will start to compare this V reference with the input voltage, and it will be giving you the output voltage depending upon the polarity of the highest voltage. For this, we will be having the waveforms like this. If the input is positive here, if the input is negative here, we will be having the respective types of waveforms. I hope you have understood this one. If you have not understood, go through the video again and again. And if you have any type of doubts, write in the comment section. I will explain again. I will clear those doubts. Thank you.